Hello everyone, welcome to a new video on the LSA encryption algorithm. Today I'm going to show you a numerical example. I will encrypt a very short word using small groups and a very limited alphabet to keep the calculation manageable. So without further ado, let's dive into the math. We will encrypt the word dead, all right? And we're going to use only the letters A, B, C, and D. Okay. First remember that we call our sender Alice, our receiver Bob, and they both agreed on 3 secret numbers. Since our word is going to be 3 letters, then we have to run the algorithms from the beginning to the end 3 times. That's why they agree on 3 secret numbers. We don't care how they know these numbers. Maybe one whispered on the other's ear and then they separated and they both remember these 3 numbers. Okay, so we call these numbers K. Let's write the letters here of our message. Okay, and we have our K1, let's say is 6. K2 is 9. K3 is equal to 12. Okay, now remember we want a number n. We call n1, obviously n1, n2, and 3. And this integer n must be greater than 6, and it has to be in the form of p to the power t, or 2 p to the power t, or p is prime and t is a positive integer. So the n1, so n1 is 7. Since 7 is greater than 6 and is written in the form of prime numbers, which is 7 to the power 1. Now, n2 is equal to 10. Note that 9 would work for us because 9 is in this form as 3 to the power 2, but we need n be strictly greater than 9. So and 10 is in the form of 2 times 5, which is prime to the power 1, and 3 is equal to 13. Okay, let's erase this. Okay, so at this point they they both list the element of respectively U7, U10, U13 in ascending order. So let's do it. And we have that U7 is equal all the integers up to 7, since 7 is prime. So 1, 2, 3, 4, 5, and 6. Then U10 is equal to 1, 3, 7, and 9. U13 is equal 1, 2, 3, 4, 7, 8, 9, 10, 11, and 12. Okay. Then remember we have the first 4 letters of the alphabet, and we're gonna match them this way. We're gonna wrap these 4 letters around. So A, B, like, let me write another color, so that at each element corresponds a letter. So A, B, C, D, A, B. And here A, B, C, D, A, B, C, D, A, B, C, D, B, C, and D. Awesome. Okay, now it's Alice's turn. they both know this and they're ready to go. So Alice has to send the word dead. So she's going to encrypt the first letter D using U7. So let's find the representative of the letter D out of U7, which is, there's only one, which is this one over here. So for the letter D, Alice will do 1 times 2 times 3 times 4, which is equal to 24. Mod 7 is congruent to 3. And this is our C. This is our little c. Okay, the first part, the first element of the tuple that composes the ciphertext. Now she has to check that multiplying this by this number here does not generate an element congruent to -1 mod n. Otherwise she would have to communicate it to Bob in as sigma. So we do 3 times 6, which is equal 18, mod 7 is equal 4. Okay, so if we had to list sigmas over here, we have no sigma. Okay, obviously if I continue multiplying and I'm multiplying this by 5, I will surely, by Gauss's generalizations of Wilson's theorem, I will generate the element congruent to -1 mod n. So we don't have any false -1s congruent to elements congruent to -1 mod 7, so we can write our ciphertext. Let me write in red. C equal little c, which is 3 and 0. Okay, so this is for the first letter. Let's go with the second one. Let me try to draw a line. Okay. Second one, the letter A. Here we also have only one choice, so our C is going to be 1. In fact, 1 times 1 is 1, mod 10 equal 1, and this is going to be again our C. And also she'll have to go through what Bob will do to make sure that Bob will not find any other elements congruent to -1 mod 10. In case there will be elements, then she'll communicate it to Bob in form of sigmas. So let's do it. So she starts multiplying 1 by the first element in descending order, so the greater number. So 1 times 9 equal 9. Mod 10 is indeed congruent to -1. Okay, so congruent to -1. So if we list all the sigmas, this is one of them. See it this way: by choosing sigma as 1, is like Alice is saying to Bob, "Hey Bobby, I know that you think that since you have a congruence to -1 mod n, you think you multiplied all the elements of the group, but no, I checked for you before that and it's not the case, because I found another element that is congruent to -1 before that, before the one you're looking for. So skip this, continue multiplying. This is not the one you're looking for." Okay, then let's try the next one. So we have 9 times 7, which is equal to 63. Mod 10 is congruent to 3, so in this case is non-1, so we have 0. The next on the list by the theorem will produce an element congruent to negative 1 mod n. So this is the true one, and we don't have to list it as sigma. Our research is over, and we can write, in this case, C equal, we said 1 by this is our element. How many sigmas are here? 1. Okay, and that's for the second letter. Let me try to draw another line. Okay, now for this one, we have to encrypt the letter D, so let's take this one over here. Okay, so Alice will do 1 times 2 times 3 times 4 times 5. We're gonna, okay, let me write it down. It's actually 8 factorial over times 4 times 5 times 6 times 8, which is equal to 40,320 mod 13 is congruent to 7, and this is our C. And then again she'll check if she multiplies 7 by this elements, make sure that Bob will not encounter any other elements congruent to negative 1 mod n, except for when he'll have multiplied them all. So let's do it. We'll do 7 times the first element, which is 12. 7 times 12 equal 84 mod 13 is congruent to 6. So on the list of sigma, this is not a sigma. Now we have 6 times the next one. 11 is equal 66 mod 13 is congruent to 1. No sigma. The next one. 1 times 10 is equal to 10 mod 13 is congruent to 10, obviously no sigma. We don't have to check this one. This one is the real one because it's when all the elements will have been multiplied, and this will give me congruence to negative 1 mod n. So we have no sigma. So sigma is 0 and C is 13. Let's write it down. C equal 7. Did I say 13? Well, I meant 7 and 0. Okay? Then we have that these keys are public. These tuples go in the open, and they all can see them, but only Bob knows that these tuples have been generated by using respectively U7, U10, U13. So let's decrypt. Okay, now I have Bob. Let me copy and paste the groups so it's easier to follow. Okay, make sure it's this one. Okay. All right. So Bob receives this tuples, the ciphertext, and he knows the group. So how is he going to do? It's easy. Okay, let's do it. Bob takes this number 3 and multiplies it by the first number in descending order. Remember that Bob is seeking for congruence to negative 1 mod 7. because once he'll have that congruence, that he'll know that all the elements have been multiplied. So 3 times 6 is equal to 18. Mod 7 is congruent to 4, and he knows that this is not the number. It's not congruent to -1, so there's not even any ambiguity. So then 4 times 5 is 20. Mod 7 is indeed congruent to -1. Mod 7. Now, see, Alice communicated that there are no sigmas, so Bob knows the first element that he'll find that is congruent to -1 mod n, that is the element that Alice meant. So this is the element. It means that by multiplying this, all the group has been multiplied. So since Alice multiplied everything in ascending order, this is the number where she stopped multiplying this chunk. So this is the number that Alice meant, and we know that Alice meant D. Okay, so the first one is decrypted. Easy. The second one. Okay, Bob has 1 and starts 1 times 9. 9 is equal to 9 mod 10 is congruent to -1. So you might say, okay, this is the number that I was looking for. But Alice communicated no. He says, watch out, you have one false number that is congruent sorry, to -1 mod n. Once you find that, skip it and continue multiplying until the next one. Okay, so Bob continues the multiplication. So 9 times 7 equals 63. Mod 10 is congruent to 3. So this is not. So again, we're going to do it with this one. 3 times 3 equal 9. Obviously, mod 10 is congruent to -1. Now he already found a sigma. He knows that this one is the good one. So again, all the numbers have been multiplied. So Alice meant this element, which corresponds to the letter A. So we decrypted this one too. Now let's go with the last one. Bob has 7 and 0. So he starts 7 and he'll multiply until he finds the first number that is congruent to -1 mod n, because there's nothing, there are no false ones. So 7 times 12 is 12 equal 84. Mod 13 is congruent to 6. Now this, 6 times the next one. 6 times 11, 66. Mod 13 is congruent to 1, not this one. Let's try the next one. 1 times 10 is 10. Mod 13 obviously is 10, not this one. Next one. 10 times 9 equal 90. Mod 13 is 12, so it's congruent to -1. And here we go. He found that we multiply up to this point over here, and all the group have been multiplied. So Alice had to multiply up to here in ascending order. So this is the number, the last number she multiplied, so she meant letter D. And this is how we use the LSA, and we are done. Thank you for watching. I'll see you in the next video.